From this picture, you have guessed it correctly that today we are going to start with the chapter Machine from your physics textbook. I am very excited and thrilled about this chapter. I hope you are too. So what to wait for? Let's get started. I am Praveen Sonawane and you are watching India's most reliable and relevant channel where you get best in class study material and video lectures. Do check the link in the description box. As always, before studying any chapter, we always will concentrate on the scope of syllabus. So whatever we are going to learn today will be based upon this. A famous Bollywood movie tells us that machine is something which makes our work easy, convenient. Look at this man. He's trying to lift a load. He's trying to lift a box. So this box we can call as a load. As we have studied in Newton's first law of motion, every body tries to be in a state of rest or of motion unless it is acted upon by some external unbalanced force. So this box or a load tries to be in a state of a rest. But this man who is trying to set this box in a motion, a box is going to offer some resistive force. And this man is going to overcome that resistive force. So the man is going to do some effort to lift this box. In machine, we have to concentrate on two important factors. One is the load and other one is the effort. Load in this case is the box, the weight of the box, or a force which box is exerting to be in a state of a rest. Whereas effort is given by this man to lift this box. So we have to concentrate on two different kinds of forces. One is the load and another one is the effort. So please keep in mind that these two kinds of forces, one is the load and another one is the effort, is going to play a very important role in our first part of the chapter. And once you have understood the first part, second part will be very easy. So let us continue to our next slide. Here comes the definition of load and effort. Load is the resistive or the opposing force to be overcome by a machine. Remember Newton's first law of motion? Every body tries to be in a state of a rest or of a motion. So it offers some resistive force which is called a load. Effort is also a force, but effort is the force applied on the machine to overcome the load. Greater the load, greater effort is required. So look at this picture. A man is applying an effort and there is a load on the other side of the effort, and in between we have a pivoted point. Load will try to remain in state of a rest, whereas a man will apply an effort or a force to bring it in a motion or to move the load. So here we have understood what is load and what is effort. If you have any doubt, please let me know in the comment box. So now we are going to study about the uses of this simple machine. We already have studied that machine is something which makes our work easy, convenient and safe. As per your textbook, there are 4 uses of the machine. Number 1, it can act like a force multiplier. Then it can also act like a speed multiplier. Third, it also helps to change the direction of the applied force. And finally, fourth, it helps in changing the point of application of force. Let's see them one by one. So use number 1 is it acts like a force multiplier. We can consider the example of this jack which is used to lift a car. Is it possible for us to lift a car with our own strength, that is manually? Absolutely not. We can't apply that much of force or effort to lift a car. So what we do is we use a simple machine. So here jack is that simple machine which is going to act as a force multiplier. We are going to apply a small force which will be multiplied manifold to give us a large force, and so that car can be lifted. So let's move on to the next example where it acts like a speed multiplier. Now this is very important to understand, because I have seen that most of the student does not understand how a machine can act like a speed multiplier. Here it is not that we are sitting in a car or a bike and we are going high speed. Let us consider an example of this scissor. This scissor is a speed multiplier. So you will be confused how this scissor is a speed multiplier. In your mind you might have thought that a car or a bike is a speed multiplier. We just sit in a car and we drive it faster and faster and faster, but not a scissor. So how scissor act like a speed multiplier? In case of this scissor, one arm which you see in a yellow color is the effort arm, because we apply the effort over there, and the other arm is the load arm, which is used to cut a cloth or paper or something else. You will see that movement of the load arm is very less. That is, you move load arm very less by a bit. But what you see is the effort arm, which moves a greater distance. So by moving the load arm in a smaller quantity, in a same time, load arm is moved in a larger quantity. Since a load is moving a smaller distance, at the same time, effort is moving a larger distance. So scissor is considered to be a machine which acts like a speed multiplier. So let us now go to the third use of the simple machine. As we have discussed earlier, the next use of the simple machine is that it helps to change the direction of the force. Now look at picture number 1. There we have a mass of 100 kg. Suppose a man tries to lift this mass against the force of gravity. So definitely he is going to find it difficult, or maybe even he can get a slip disc. So why to risk when we have a simple machine called pulley? So what we do in pulley is we change the direction in which our effort is applied, and this direction is as per our convenience and as per our safety. So when you pull this mass, you will see that it has been changed to a point which is convenient to us. You also see that we apply our effort in the direction of the gravity and not against the gravity. So gravity is also on our side, which is helping us to lift this mass. Isn't it a nice way in which simple pulley can help us? You can also read the example written over here, in which we see a bucket full of water instead of this 100 kg mass. So fourth use of simple machine is we change the point of application of a force. See, in a case of a bicycle, suppose if you are riding a bicycle, you need to move the wheels of the tire so that cycle is set into a motion. But you don't directly apply the force on the wheel. Instead, you apply your force or your effort in the pedals, which moves the chain, and chain in turns moves the wheel. So here we see that simple machine can also be used to change the point of application of force. As in this example of a bicycle, the point of application of a force is shifted from wheels to the pedal. So this was the fourth use of a simple machine. I'm sure it is very easy for you to understand. Now this is the wrong notion that machine reduces our work. No, my friend, machine never reduces our work. It only makes our work easy. Now the principle of machine states that work input is always equal to work output. So if you think machine is going to reduce your work, no, it is not going to reduce your work. It is going to make your work easy, convenient and safe. So now let us concentrate on the principle of a machine, that work output is equal to work input. Let us concentrate on this equation. We already have studied in a previous chapter that work is equal to force into displacement. And we know that whether a force or a load, both are kinds of forces. So work input will be effort into effort term. This is same like force into displacement. Effort is a force and effort arm is the displacement produced by your effort. On the other hand, you see work output is equal to load into load arm. Again same, work is equal to force into displacement. Load stands for force and load arm is the displacement of your load. So we can say effort into displacement of effort is equal to load into displacement of load. On crisscross, that is cross multiplication, you get is load upon effort is equal to displacement of effort upon displacement of load. So we will try to separate the left hand side and the right hand side. So left hand side, load upon effort, gives us a new physical quantity called mechanical advantage. So here I introduce a new physical quantity, mechanical advantage, which is again very important. So please remember this formula, mechanical advantage is equal to load upon effort. On the other side, from the right hand side, we got displacement of effort upon displacement of load. This right hand side gives rise to a new physical quantity which is called velocity ratio or VR. So from the principle of machine, that is work input is equal to work output, we got two new physical terms. We got two ratios, one on the left hand side and other on the right hand side. Left hand side was load upon effort, which is called as a mechanical advantage or MA. On the right hand side, it is displacement of effort upon displacement of load, which is said to be a velocity ratio or VR. Henceforth, these two physical quantities or this two physical terms, that is mechanical advantage and velocity ratio, will be used very frequently. Also, we are going to derive a relationship between them. So here we have two results. That is mechanical advantage is equal to load upon effort, whereas velocity ratio is displacement of effort arm upon displacement of load arm. Please concentrate on both the equations very carefully, because in one physical quantity, mechanical advantage, you have load in the numerator, whereas in velocity ratio you have load arm in the denominator. Please note that. And same thing applied for effort also. In mechanical advantage, effort is in the denominator, whereas in velocity ratio, effort arm is in the numerator. But कुछ तो गड़बड़ है दया, because physical quantity says velocity ratio, but here we have a ratio of displacements. This is the gadbad. So let us try to find out what is the crux of the problem. So let us say velocity ratio is equal to velocity of effort arm upon velocity of load arm. So let us say velocity ratio is equal to velocity of effort arm upon velocity of load arm. We all know the formula of velocity which we have studied in 9th standard. That is, velocity is equal to displacement upon time. So we have replaced velocity in the numerator as well as denominator with the formula displacement upon time. So velocity ratio is now displacement of effort arm upon time upon displacement of load arm upon time. So time and time will get cancelled, and we will get velocity ratio equal to velocity of effort arm upon velocity of load arm, which we started with, and then we got, after cancelling time from both the denominators, velocity ratio as displacement of effort arm upon displacement of load arm. Now $1,000,000 question is that, is time equal for the displacement of the effort arm and the displacement of the load arm? So answer is yes. Now look at this example. If you see this pair of scissors, so when you move by this distance moved by the load arm is only this much, such a less distance, but at the same time, so much of distance is moved by the load arm. But you have to notice that the time taken for this movement of the load arm as well as the movement of the effort arm is same. In the same time, different distances are moved by the load arm and the effort arm. If you don't believe me, you can take a pair of scissors and can find it out for yourself. Now it's time to learn the definition of mechanical advantage and velocity ratio. Mechanical advantage or MA, it is the ratio of load to the effort. And remember, mechanical advantage is the ratio of two forces. So it has no unit As we all know, ratio does not have a unit. And what about the velocity ratio? It is the ratio of the velocity with which effort moves to the velocity with which load moves. Remember, we have taken the example of pairs of scissors. So, velocity ratio is velocity of effort upon velocity of load. Or in other words, we can say displacement of effort upon displacement of load. Remember now how time was cancelled both from the numerator and denominator. Please note these formulae carefully and try to understand it. Most of the students find physics very difficult. The reason is that they concentrate only on the theory. But the important part of the physics is its equation. Now you should know how this equation is used in different situations. If you try to understand how these equations are applied in different situations, so remember, physics will be very easy for you. There will be no subject easier than physics. As you move ahead in this chapter, you may assume that things are getting more and more tougher. But no re Baba, it is physics. If you understand the equations properly, if you understand the equation properly and the different situation in which they are used, remember there is no subject easier than physics. So in physics, equations are very important. Try to understand the equations. Try to understand the situations in which these equations can be applied. And see, definitely you will come in your exam with the flying colors. So in uses of physics, we have seen that how simple machines can be used as a force multiplier, as a speed multiplier, or to change the direction of the application of force. So try to understand this. What do we understand by a machine which multiplies the force or a force multiplier? That means we apply a less force and we move a greater load. So force multiplier is a machine in which load is greater than the effort. Now try to recall the formula of mechanical advantage. It is load upon effort. So load or a numerator is a greater value and effort or a denominator is a smaller value. So mechanical advantage is greater than 1. So yes, my student have heard this from me 1,000 number of times that the subject physics does not has a language. Maths is its language. And try to understand this. You have a fraction with a greater numerator and a smaller denominator. So your answer which you are going to get will be greater than 1. Say in case if numerator is 5 and denominator is 2. So your answer is 2.5. That is greater than 1. So your mechanical advantage is load upon effort. And load is greater than effort, so mechanical advantage is greater than 1. Whenever a mechanical advantage is greater than 1, then your machine is a force multiplier. And vice versa. Let us come to point number 3. Hang on, we will come back to point number 2. Look at the point number 3. Here we have effort greater than the load. So we have to apply lot of effort to move a little load. So is that machine helpful for us? The answer is yes. We have seen a pair of scissors. Maybe we apply a more effort, but we cut a paper faster because placement of the load arm is very fast. So the machine in which effort is greater than load, that machine is not a force multiplier, but that is a speed multiplier. That machine tries to save your time. You remember now in an example of machine, you have moved your effort by a smaller distance in a pair of scissors. At the same time, the effort has moved or the effort arm has moved a larger distance. Now let us come to the third case where load and effort both are same. When your numerator and denominator both are same, then your ratio is going to be equal to 1. As in case if you have numerator 5 and denominator 5, so your ratio is equal to 1. So if that is the case, if load is equal to effort, then mechanical advantage is equal to 1. And when mechanical advantage is 1, then that is a simple machine which is used to change the direction of the applied force. So here we have all three cases. Mechanical advantage greater than 1, then that machine is a force multiplier. Mechanical advantage smaller than 1, then that machine is a speed multiplier. And when mechanical advantage is exactly equal to 1, then that machine is a simple machine which is used in changing the direction of the applied force. Remember this and move ahead. Whatever comes next is going to be very easy. So now we are about to learn the last physical quantity, which is called efficiency. Now what is efficiency? If you remember, I have told you the principle of a simple machine. Over there we have seen that machine never reduces our work. It will only make our work easy, convenient and safe. So work input was equal to work output. But what if we take ratio of work input and work output? So yes, your efficiency is the ratio of work output and work input. And generally it is represented by a Greek symbol eta. Eta just represents English letter N. Only difference is that it has one long leg. So here we have formula of efficiency, that is work output upon work input. So whenever we study any new physical quantity, next thing we learn is its units. So what is the SI unit of efficiency? It is a ratio, just like a mechanical advantage or velocity ratio. So efficiency too does not have any unit. But hang on, wait. During solving of numericals, we express efficiency in terms of percentage. So whatever ratio you get, multiply that by 100% and you will convert that ratio into percentage. Now we are going to establish a relationship between mechanical advantage, velocity ratio and efficiency. So just now we saw that efficiency is equal to work output upon work input. Formula for work output will be load into displacement of load, and formula of work input is equal to effort into displacement of effort. Remember, output is related to your load and input is related to your effort. So when you write work output, it will be load into displacement of load, as output is related to the load. Upon work input will be effort into displacement of effort, because work input is related to your effort. So in next step, we separate this ratio. We take efficiency as load upon effort multiplied by displacement of load upon displacement of effort. Now it is quite obvious that efficiency is equal to mechanical advantage multiplied by displacement of load upon displacement of effort, because mechanical advantage is equal to load upon effort. Suppose if we have to insert a velocity ratio over here, so whatever we have in the numerator here, that is displacement of load upon displacement of effort, is not the velocity ratio. Velocity ratio is reciprocal of that. So we will do a minor change. So we will change this second ratio. And mathematically, you need to have a strong base of maths if you are learning a physics, because physics does not have a language. Its language is maths. You should have a certain basic understanding of mathematics. You will see that numerator, which was the first line, has become a third line in the denominator. Mathematically, this is possible. So what can I say now? So I have efficiency is equal to mechanical advantage upon velocity ratio. See, this is very important question from your examination point of view. They ask you to write a relation between mechanical advantage, velocity ratio and efficiency. So you have to write the relation in terms of equation, and this equation is efficiency is equal to mechanical advantage upon velocity ratio. And as I told you, you can express this ratio in terms of percentage. How do you do that? Simply multiplying this ratio, mechanical advantage upon velocity ratio, by 100%. So your efficiency will be expressed in terms of percentage. This brings us to the last part of this chapter, that is a difference between the practical machine and the ideal machine. We were talking about the mechanical advantage, velocity ratio and efficiency, but all the situation considered by us were the ideal situation. Does practically this situation apply? So I will say yes, but not totally. This gives rise to this situation, that is difference between ideal machine and practical machine. So let us differentiate. Let us start with the principle of the ideal machine. It says that work input will be equal to work output, but it is not possible. If we are using any machine, whatever work we do as a input work, same output work we are not going to receive back. Why? Let us take an example of an electric bulb. We supply an electrical energy to get a light energy. Energy is nothing but capacity to do work. All the energy will not be converted into light energy. Some part of the electrical energy will be converted into heat energy also. So this heat energy is the wastage of energy, which is also called as a dissipated energy. So when you think practically, that is when you consider a practical machine, all work input is not converted into work output. Some work is wasted, some energy is wasted to overcome the resistive forces offered by the moving part of the machine. So efficiency is 100% only in the case of the ideal machine. It is not true for the practical machine. Practically, you will always get efficiency less than 100%. In an ideal machine, work output is equal to work input. Efficiency is 100%, and there is no wastage of energy, that is no dissipation of energy. These are all ideal conditions only possible in the ideal machine. An ideal machine is a myth. It does not exist. In our real world, we get only practical machines and not the ideal machines. Now let's move on to next slide of a practical machine. See this statement here. In practice, no machine is ideal. That proves my statement that ideal machine is just a myth. It is not a reality. In reality, there are moving parts in the machine. Secondly, if we are using any wires or string in our machine, so that wire or string is not perfectly inelastic. Means the cables or wires or the strings which we are using in a machine, they tends to stretch, and because of this stretching there is a loss of energy and loss of work output, which results in efficiency less than 100%. So efficiency of practical machine is again less than 100% because of the strings or wires or cables which are used in our machine. Any and every machine are made up of different parts. Those parts are not perfectly rigid. They tend to change their dimension. They very easily get wear and tear. And as they become older and older, vibration in the machine increases, and that reduces the efficiency further. Also, these moving parts are not weightless or massless. So they have their own mass, and machine has to overcome that mass. So that also lead to efficiency less than 100%. Hence we have seen that there is a loss of energy and work output is less than work input. So efficiency in a practical machine is always less than 100%. So this part is a theory part, not like the equations which we have studied when we were learning about mechanical advantage, velocity ratio and efficiency. So this theory part generally students find it easy to understand. If you still find it difficult, let me know by writing in a comment box. So finally, last slide of this part, but not the last slide of this chapter. We will continue this chapter in part 2 where we are going to study about pulleys. And let me know if you want part 3 on the numericals. I'm waiting for your reply. So here are 3 points to ponder. These 3 points are very important from your examination point of view, because a question related to one of these 3 points is always there in every paper. So for point 1, we have already studied a mechanical advantage, velocity ratio and efficiency. We have seen that efficiency is never 100% for a practical machine. Efficiency is the 100% only for the ideal machine. Same is true for the mechanical advantage. For practical machine, your mechanical advantage will always be less than the mechanical advantage machine supposed to give. So this makes us conclude that efficiency is never 100% and mechanical advantage is also less than what machine supposed to give. But this is totally different for the velocity ratio. Velocity ratio is always constant. Mark my word, velocity ratio is always constant. And in examination, you are most likely to get this question, why velocity ratio always remains constant and not mechanical advantage or efficiency. So reason is that velocity ratio does not depend upon the dimension of the machine. That it does not depend upon the weight or the friction of the moving part, where this factor reduces mechanical advantage and the efficiency. Let me go back to the example of a scissor. Always displacements of the load arm and the effort arm will remain same, but mechanical advantage and efficiency will go down in case if there is any wear and tear in the machine. When your machine or when a pair of scissors is absolutely new, you will see that it is working very efficiently. But as the moving part, as the part becomes loose, so they tend to lose their mechanical advantage and efficiency. So mechanical advantage is always less than velocity ratio and efficiency is always less than 1 or the 100%. Please keep these 3 points in your mind. Please think over it. Also remember that I have my app called PrepWin app on a Play Store. You can download that app for more video lectures, for detailed notes of this chapter, other study materials, and even you can take the online test. So the PrepWin app on the Play Store will be very helpful for the preparation of your examination. So we are ending this chapter here and I will see you in the another part of this chapter. Bye.